Today we will be evaluating limits of functions, and after this lesson, you should be able to evaluate limits confidently. We first evaluate the limit of 3x divided by x minus 2 as x approaches 2 from the left. Please take note of the symbol used to indicate a left-hand side limit, and this will simply indicate that x approaches 2 but always with value less than 2. So when we evaluate the limit of 3x divided by x minus 2 as x approaches 2 from the left, then we have to take note that x will be approaching 2 always with values less than 2. Hence, the denominator x minus 2 would be approaching 0 but always with negative values. And therefore, this ratio of 6 with something that approaches 0 but always with negative values would be approaching negative infinity. And therefore, we say the limit of 3x divided by x minus 2 as x approaches 2 from the left is one that is unbounded, approaching negative infinity. In case we're given a piecewise function, as we have here, where f of x is defined equal to 2x minus 1 whenever x is less than or equal to 4, but is defined equal to x squared plus 2 whenever x is greater than 4. Evaluating the limit of f of x as x approaches 4 would require that we evaluate the left-hand side and the right-hand side limits of f of x as x approaches 4. This is because f of x is defined differently to the left of 4 and to the right of 4. So if we will evaluate the right-hand side limit, evaluating f of x as x approaches 4 from the right, then we will be using this definition of f of x whenever x is greater than 4. So we evaluate the limit of x squared plus 2 as x approaches 4 from the right, and this will just give us an 18. In evaluating the left-hand side limit, the limit of f of x as x approaches 4 from the left, we will be using this definition of f of x because this is how f of x is defined whenever x is less than 4. Hence, we evaluate the limit of 2x minus 1 as x approaches 4 from the left, giving us a 2 times 4 minus 1 or 7. Please take note that in this case, the right-hand side limit of f of x as x approaches 4 is not equal to the left-hand side limit of f of x as x approaches 4. That is, 18 is not equal to 7. Thus, we conclude that the two-sided limit, that is the limit of f of x as x approaches 4, does not exist. Okay, let us now investigate the limit of x plus 2 divided by 5x squared plus x minus 3 as x approaches positive infinity. The initial investigation of the limit of the expression as x approaches positive infinity would lead us to the indeterminate form infinity divided by infinity. Again, this is not acceptable as a limit. So, what we need to do to be able to come up with a conclusive result is again to transform the expression x plus 2 divided by 5x squared plus x minus 2 into a form wherein evaluating the limit would give us something that is finite. Now, the way to transform is to divide both members of the numerator and the denominator by the highest degree x factor, which in this case is x squared. So, dividing x plus 2 by x squared and dividing 5x squared plus x minus 3 by x squared, we come up with a fraction 1 over x plus 2 over x squared all over 5 plus 1 over x minus 3 over x squared. This is now the expression that we are going to use to determine what the limit is as x approaches positive infinity. Now, when x approaches positive infinity, 1 over x, a value would be decreasing approaching 0. For that matter, all the factors or all the terms here where we see x in the denominator will have limit of 0 as x approaches positive infinity. Hence, evaluating the limit of the expression as x approaches positive infinity would lead us to having 0 divided by 5 or 0. This result now would lead us to the conclusion that the limit of x plus 2 divided by 5x squared plus x minus 3 as x approaches positive infinity is 0. Let us now investigate the limit of the ratio of the square root of x plus 2 minus 2 to x minus 2 as x approaches 2. Again, the initial investigation of the limit of this expression would lead us to a 0 over 0 form, an indeterminate form. Again, we cannot accept this as a limit, and that to evaluate the limit of this expression, we need to transform this ratio into some other form that is equivalent, and the transformation is done by multiplying this fraction with the conjugate of the numerator. So we multiply this fraction with the fraction square root of x plus 2 over the square root of x plus 2 plus 2. Remember, whenever you multiply a given expression with, it should be with an expression that is equal to 1 so that you do not change the identity of this particular expression. So when you multiply these factors together, you end up with this expression that would simplify just to a 1 over the square root of x plus 2 plus 2. Using this expression, evaluating limit as x approaches 2, we will have the limit equal to 1/4, and therefore conclude that the limit of the square root of x plus 2 minus 2 divided by x minus 2 as x approaches 2 is equal to 1/4. On some occasion, you will be asked to evaluate the limit of an expression involving transcendental functions, such as in this case where we have trigonometric functions. Okay, so let us investigate the limit of cosine x times tangent x divided by sine of 2x as x approaches 0. Again, initial investigation of the limit would result to the indeterminate form 0 divided by 0. Just the same, because we encounter a 0 divided by 0 form, there is a need to transform the given fraction into some other form equivalent, and the way to transform is to make use of appropriate trigonometric identities. So in this case, it is to replace tangent x with sine x divided by cosine x, and replace sine of 2x with 2 sine x cosine x. Simplifying this fraction now, noting that cosine x is a common factor here, and then sine x is a common factor also of the numerator and the denominator. This expression simplifies to 1 over 2 cosine of x. And using this to evaluate the limit as x approaches 0, we end up with 1 over 2 cosine of 0, or we have a 1/2. Consider evaluating the limit of cosine x tangent x divided by x as x approaches 0. Here, the initial investigation of the limits again will give us an indeterminate form 0 divided by 0. Now, if we are going to simplify the expression cosine x times tangent x divided by x by replacing tangent x with the quotient identity sine x divided by cosine x and simplifying this expression, we end up with evaluating the limit of sine x divided by x as x approaches 0. Now, please take note that in this given form, there is no more a common factor of the numerator and the denominator. And in case you encounter a sine x over x ratio in the expression, and you are asked to evaluate the limit as x approaches 0, then you can make use of this theorem, which is the result of using the squeeze theorem, stating that the limit of sine x over x as x approaches 0 is 1. And therefore, going back here, the limit now of this expression is 1, and that will also be the limit of cosine x times tangent x divided by x as x approaches. In summary, The limit of f of x as x approaches a in general is a finite real value. Only when the limit of f of x as x approaches a from the right is equal to the limit of f of x as x approaches a from the left is equal to L, that we conclude that the two-sided limit, the limit of f of x as x approaches a, exists and is equal to L. Otherwise, the limit does not exist. When the limit of f of x as x approaches a is one that would be approaching negative infinity or positive infinity, then we conclude that there is no limiting value to f of x as x approaches a, and that f of x value tends to increase or decrease without bound. If the limit of f of x as x approaches a initially results to an indeterminate form, either of the 0 over 0 or infinity over infinity form, then the limit of f of x as x approaches a can be evaluated by first transforming f of x into a form where the limit is not anymore indeterminate. In case of f of x involving trigonometric functions, whenever the limit of sine x over x as x approaches 0 is in the expression, then the limit can be evaluated using the theorem, the limit of sine x divided by x as x approaches 0 is 1. Now that will be all for today. I will see you in the next lesson.